Okay, so this first question, a high school newspaper asked students about the main reason they use social media. The newspaper found that 45% of students use social media to post videos and or photos, 32% use social media to communicate with friends, 21% use social media to keep up with current events, and 2% use social media for other purposes. The newspaper plans to publish the results using a circle graph. If the length of the arc that represents communicating with friends is 5 centimeters long, what is the approximate radius of the circle graph? So the first thing you want to do is just get a good diagram going. And so I'm going to draw a circle. It's not going to be beautiful, but it's going to get the job done. So here's my circle. All right. I want to mark a center. It's not really the center because I didn't measure it, but it's just a diagram. So here's my radius. I'm going to mark that. It looks like that's the unknown. They're asking us to find radius. So that's why I've marked it with an R and not with a number. They've told us that the arc length that represents communicating with friends is 5 centimeters long. So I'm going to ignore all the other information. And I'm just going to put this, I'm going to inscribe an arc on here. I'm just going to make it red, okay? And I'm going to mark this as 5 centimeters. All right, so there's my arc length that represents communicating with friends. Now, the number associated with communicating with friends is right here in the problem. It's 32%. Now, that 32% doesn't help us very much because we're dealing with a circle. So 32% is going to need to be translated into degree measure. So we know that the amount of degrees in a circle, right, we're saying that's 360 degrees all the way around. Well, what you're saying when you say 32% is represented by this arc right here is that we're going to have 0.32 times 360 degrees. That's going to give us the number of degrees that is represented by this arc. So let me do that in the calculator. 0.32 times 360. Okay, so 32% of 360, listen to the language there I used. 32%, that's 0.32. Right, 32 divided by 100. That's how you represent a percentage as a decimal. Of 360 means multiplied by 360, and so this is the number you get, 115.2. So that's the number of degrees, 115.2 degrees. That's how many degrees is represented here in this arc. So let me just mark this as this right here. Let me do it in a different color, sorry. This degree measure right here, theta is 115.2 degrees. Okay, so there's two ways I can go about solving this from here. I can set up a simple proportion, and this is the one that is going to be the preferred method simply because it's probably going to be quicker and easier. So let's do it like this, 115.2 degrees, okay? That's over 360 degrees. So in other words, this is the part, the arc. And this is the total, right? 360 is the total. This is the part. It's the arc. So let me just write arc, actually. Okay, and I'm going to set that equal to another proportion. That proportion is simply the measurement, right? The measurement right here. So the total measurement in a circle is 2 pi r, but of course I don't know r. I'm looking for it, but I don't know what it is. The arc, I do know. The arc is given as 5 centimeters. Okay, so now I can just solve this proportion right here. If you don't know how to solve it, at this point in math, there's always more than one way to do it. I'm just going to show you what I might do. So to get r on top, that's going to be my goal, right? So I'm going to move 2 pi r to the other side. So I'm going to have it, it's now going to look like this. 2 pi r is going to be on the left. And on the right, I'm going to move this ratio, right? So if I do 115.2 divided by 360, let's do that in the calculator, divided by 360, that's 0.32. So if I move that to the other side, I'm dividing by 0.32. So it's going to be 5 divided by 0.32, okay? And now I'm just going to put this part in my calculator. So 5 divided by 0.32. Sorry. Work. Okay. 5 divided by 0.32, second answer. That's 15.2 15.625, but that's not the answer. So let's just write that down. 15, 2 pi r equals 15.625. And now I'm gonna divide by 2 pi to get r all by itself. Okay, so r equals, and I'm gonna go back to the calculator and divide by 2 pi. So divide by 2 pi. All right, so I get 2.4867. So I'm gonna round to 2.49. 2.49. Okay, so that's the answer, and it is actually A. It's 2.49 centimeters. That is the length of the radius. All right, so there is another way to do this. Let me show it to you, and let me see if I'll try to make it fairly quick, but it's a little bit complicated. So there is an expression that you should be aware of. It's that the length of the arc over the radius of the circle is equal to theta, but in radians. Okay, so the length of the arc was given. That was 5. I don't know the radius, as we said, right? I don't know the radius. Of course, we just found it, but you know what I mean. So I don't know the radius. That's an unknown. That's what I'm trying to find. And then the theta in radians, all I have to do is take the degree measure that I already solved for, 115. Or 115.2, I would need that number. I would need to calculate that number no matter what, no matter which method I use. So all I need to do now is just convert this 15.2 degrees into radians. How do I do that? I use the factor label method. I'm going to multiply by a conversion factor, and that conversion factor is important, and you need to know it. It is 180 degrees is pi radians. Okay, and so if you put that in your calculator, let me pull up the calculator. So 115.2, as we said, divided by 180 degrees, but then multiplied by pi. Okay,